The first part of the engineering design process is ask. Before we could brainstorm ideas for our fountain, we had to consider the constraints of the project. Those constraints included a $40 budget, a maximum area of 2 feet by 2 feet, minimizing splashing, and no live animals. Required components included water must flow against gravity, and either water must act as an actuator, we not use an electric pump, or we design and construct laminar flow water movement. The next step was to imagine what our fountain should look like. We brainstormed some ideas and created some rough draft 3D models and drawings. We decided that we wanted to use water as an actuator for our required engineering component and to incorporate a water wheel. Next, we planned how we wanted our fountain to officially look like. We drew diagrams of the hourglass shape we settled on and the length and width of the pieces of wood we needed for the base. We then dedicated a day to gather our materials: wood, tubing, a pump, and plumber's putty. We decided we did not need the other materials shown in the picture, such as spray paint, nails, and a bucket. To put together last-minute changes, we used hair ties and duct tape.
When we went to create our fountain, we started by making a wooden box to house the entire thing. We then put a small plastic bin in the bottom as a water reservoir, but later decided to waterproof the box and use the whole thing as a reservoir. We then created the vertical wooden supports in an hourglass shape. Next, we made a water wheel out of a circular piece of wood with notches cut in to hold the wooden paddles. Then we attached the wheel to the vertical struts through an axle. Then the tubing was cut and attached to the pump, then split into 2 directions, traveling up the supports to the top where the water shot out and fell onto the water wheel to spin it. Some improvements that could be made are to reduce splashing from water hitting the water wheel. Tubing at the top could also be held in place better, as currently it becomes occasionally unaligned, making the falling water miss the water wheel. A stronger pump could also be used to have the water shoot up higher in a more spectacular fashion.
We encountered a few challenges during our design process. First, we had to stop the water from dissolving the glue between the sheets of wood that formed the box. We used plumber's putty to seal up the cracks so the water couldn't get in. Next, we needed the water to turn the water wheel effectively, smoothly, and consistently. We adjusted the tubes so that they would hit the paddles just at the edge to ensure the most force was being applied to the wheel. However, the tubing was stiff, so we had to use duct tape and hair ties to move it around and get it just in position as we needed.
Put a picture underneath here. Oh my god. I didn't even think of that.
At FEDD, our fountain ran smoothly for the entirety of the session. While it was functional, it wasn't the most aesthetic, and we think we lost some points there from the judges. Also, the water splashed off the wheel just outside the box, so we think that might not have helped us either.
So some things we would change is that we would not have done a water wheel, as that did quite a lot of splashing and was against what we kind of wanted to do. We would probably do more of the laminar flow, as that would reduce a lot of the splashing, which was our biggest problem. I would look into different pumps and make sure the one you get is strong enough for your design. That was a huge problem for us. And any tubing you get, make sure it is flexible enough for what you plan to do, because that was also a huge problem for us.